Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, an argument for global data networks with special guest Alan Evan, Principal Technologist at MacroMeta. Alan, welcome to the show.
Cheers, mate. Cheers, Darren. Nice to be here.
Hey, Alan, we've been talking for, 4 months? Has it been that long?
It could be longer. Yeah, it could be longer. Feels like it.
Could be longer. Yeah. Oh, thanks. Yeah. I have been told I'm long-winded, but not that long-winded.
No, I think it's been.
We've been actually. Yeah, about 6 months. Wow. You and I wrote a white paper together specifically on this. And it was actually pretty cool because we met every Wednesday, my morning, your afternoon, for a good portion of that 6 months and talked about things. It was a little bit crazy.
It was great
but,
time. Very, very early for you.
It was
very convenient. Yeah. Yes. Next one we'll have to reverse the roles where I get up.
Yeah, there you go. You get up at 3 a.m.
Yeah, exactly. There you go.
All right. Hey, let's dive right into this. What do you feel is the most important aspect as we move forward into 2023 and beyond? We've got data spread all over the place. What do you feel is kind of the key aspect of managing this data all over the place?
I think first, that's a great question, by the way, but I think the first point when I think about it, it's, I hate to use the term paradigm shift. People always use it, don't they? Paradigm shift. But the big shift for me, I think, when I think about enterprise architectures and applications is, at some point you always get to the data, right? There's a data problem or a data use case behind it all. That's what drives these applications. And I think up until very recently, what we call legacy approaches to data processing and data management have been largely okay. And when I think about that, I'm looking at, big data, batch-based processing, generating insights, and then, a data scientist looking at, that and querying it and exploring it, and then, trying to produce some sort of actionable insight that then they will then use and feed into the rest of whatever business they are running, right? And I think with the advent of modern high performance networks, connected things, so Internet of Things, we're seeing an exponential increase in data. And the challenge with that is, you no longer really can afford to have, or the only way to look at insight, having a human in the loop. It can't be your only solution for these modern applications and the solutions. You can't have a human there waiting for data to be pulled from wherever it's being generated at whatever cost, put into a big data lake, and then, start to turn the handle on it and try to generate some insights, and then sometime in the, later on, try to do something about it. And I think that the big shift here is that from the legacy big data, slow data approach to how do I deal with billions of connected devices, where the value of data is fleeting, and I need to be able to action that data in a very short order.
I like how you put a temporal aspect to data and its value. And we talked about this several times, and we'll talk about it more today, that data as it ages does not become more valuable. It becomes less valuable. For actionable insight, which I think is fascinating perception. As you said, it's kind of today when we look at data science and insight, most of it is this big methodical, I got to do this, I got to do that. It's just slow, right? And I will get insight on what happened weeks or months or even years later. And there's no sense of urgency. But I think there is now. There's a sense of urgency, but we haven't quite caught up with it. Would you agree?
Yeah, totally. I mean, I think there's no canonical view of this, in my opinion. There's lots of contributing views that I think if you expose yourself to the trends and initiatives that are going on across multiple industries, you start to see a lot of um, synergies between them, right? And I think the one that stands out to me is, when we first started talking about, artificial intelligence, for example, it was, well, we collect all this data. It's got to be good data, so we have to clean it. We then want to use it to train our models. And, that's great. We've now got a model that's trained. We can now ask it questions and get an insight out of it effectively, removing the human from the loop, albeit after, the human has now moved roles. They're now no longer providing the insight. They're now training a model to provide the insight. So it's not, I don't want to get into that kind of thing, but even once you've trained the model, so to your point of data value, I think, real-time data has immense value. Historical data has value when you put it in the context of training a model so that it can act on new real-time in the moment data, right? And the challenge there is that you build these models and then they're sitting out in a central location somewhere when the data is typically being that you want it to act upon is being generated, in the human world, right, right at the edge, and
Right out
so
on
you
the
end up
edge, right?
introducing, yeah, so right on the edge, the real edge, where we all are, where our devices are, and that having a 300 millisecond or longer round trip time to my AI inference to get an insight kind of defeats the object of building the model in the first place, because I'm looking for a real-time actuation and insight into what is going on in the moment. I can't afford to have that pushed out centrally, right? I need it close to where the data is being generated.
Well, and that brings up something you came up, I thought was brilliant in our paper, which was the 3 laws of edge computing. You
Yeah.
called it the laws of physics, the law of economics, and the third one, what was it? Oh, the law of the land.
Oh, law of the land. Yeah,
Fascinating
exactly.
insight. Yeah. So explain those 3 laws real quick. What?
Sure.
Why would you put laws on edge? Edge is the Wild West. We can do whatever we feel like, right?
Well, we should definitely go into it with that mindset. It's not about putting laws on it. It is about thinking,
It's about reality, right? What's really
yeah,
happening.
it's about sort of, so when I think about the laws, they're more than I think laws is probably a bit marketing sort of term, but more guidelines as to how
I
to
like
think
it.
about what kind of characteristics, requirements does your application have, and how do you kind of classify them, right? And the first way to think about it is, the laws of physics. So you can think of an edge application in the context of the laws of physics, usually from like the speed of light, and the connectivity between endpoints. So an edge application by definition is one that reduces the distance between endpoints. All right, okay. So having a low latency connection, in MacroMeta's sense, we have a sub 50 P90 round trip time. Okay, much lower in other places, and but then you've got the concept of propagation delay as well. So when I think about the laws of physics, I'm thinking about it in a couple of different dimensions as well. So not just the distance between endpoints, but also how long does it take to process data, and what technologies should I use to actually handle that processing of data. So I've worked with enterprises in the past who have attempted to build an edge solution, and they've used some of these legacy big data kind of approaches, and they've deployed it at the edge and completely negated the benefit from the laws of physics perspective. So yes, you've got a low round trip time, but the tech you put in place is still processing data like 10 years ago. So therefore, there's no benefit of doing it, right? So you have to, when you think of the laws of physics, it's, as I say, it's a combination of round trip time, latency, but also the propagation delay of the data through the system itself. So
Well,
the
I'm
second
glad you brought that up, because in some cases, right, we have edge devices that are so far out at the edge that the connectivity and those laws of physics, like you said, just make it that latency is there, and you've got to deal with it. You can't just say, well, I'm just going to ignore the speed of light. I'm going to ignore that my device is on a satellite that's 1,500 miles away, or
yeah,
even further,
yeah,
or
yeah.
on the other side of the world, and I'm trying to connect these two endpoints that are 15,000 miles away. You're going to have some latency with that.
Well,
So I'm
yeah,
glad you brought that point up.
well, yeah, and I think to that point as well, when you talk about the laws of physics, it's like you think about, put yourself in the perspective of the enterprise and their application, and the user experience they want to have. So I can't think of an application where an enterprise where they don't want to have a good experience for their clients or their consumers or their devices or whatever, right? The challenge is,
Right.
and you can solve that quite simply by reducing, the round trip time of the endpoints, for sure. But it's like, yes, we mentioned propagation delay, so I'm not going to go into that again. But then the next challenge is, how do you handle that on global scale? How do you provide a consistent experience for whatever your endpoints are, your devices, your humans, whatever, on global scale? Rather than what you get today with a centralized approach, where somebody in New York is getting a great experience, and somebody, on the other side of the planet is getting a really poor experience. It's like, well, how do I enable those devices, those users, to interact with the application with, high performance, the law of physics, but at global scale? Okay. And the edge needs to take those sorts of things into account.
Well, and this brings up the next point, because most people would say, well, just have more substations or endpoints connected, and just make short hops between things. But then you have the law of economics, right?
Mm.
I can't deploy a million devices out there. It's too expensive. So explain a little bit on your law of economics. We got to make this reasonable, right? It can't just
Yeah, yeah. Well, the law of economics, when I thought about this, it's as much about what you said, but also includes really that the value of that data itself, and this comes back to the value of data is fleeting. Okay, so it's like, as we go forward in, with into 2023 and beyond, the amount of data that's being generated from the edge is just growing exponentially. I forget the exact numbers. We can probably look that up, but it's zettabytes, I think, of data that's predicted to be generated from the edge. And it's like, how are you going to process that? At the top of our chat, we talked about, the old sort of architecture or process of backhauling all that data to a central location, and then a human trawling over it. It's like, is that really going to be cost effective? I mean, from a data processing perspective, is that the most cost effective way to do it? There's a lot of noise in the signal as well when you do that. Is all the data you're backhauling, is that the valuable to you, or is it
is it
specific
valuable?
insights?
Yeah.
Yeah. Is it the insights that value, or is it the data that's valued? Did you really want to pull all that data, or just a subset of it? Or did you not want to pull a subset? Did you actually want to process it and get to the point where you're converting raw data into valuable insight, as it's being generated, so you can actuate it? So the law of economics is not just about moving data from one location to another. It's about monetizing data, right? It's about whether that's saving, money, whether or not it's generating new revenue, any of those things. It's like the economics around the data itself. And if you process the data at the edge as opposed to at a central location, does this open up new economic models and business models for you as a business that will mean the difference between going out of business or being successful, having happy customers or unhappy customers?
Right. Okay. Let's talk about the third law, right? Because we got physics, economics, and now the law of the land. Are you applying the privacy laws here? Is that what you're talking
Yeah,
about here?
yeah, totally. So the law of the land is a fun one, isn't it? I mean, one of the, we're also looking at a model here where, a lot of enterprises have been, yeah, sure, a lot of enterprises have done the whole lift and shift, and they've put their applications in a central location. But there's an awful lot of enterprises out there that can't do that. And they have a heavy investment in on-prem data centers, and these can be for a number of different reasons, right? It could be the privacy aspect of it. It could, and those could be, depending on the industry that you're talking about, that could be a legislative or a regulative requirement for them to do data processing. So it's financial data, maybe it's close to a stock exchange, maybe it's a manufacturing company, maybe they have policies in place that they've imposed on themselves, that this is our policy of how we want our data to be managed. But they're going through a transformation where they really want to take advantage of, the kind of modern sort of OpEx driven business model of cloud computing, whilst maintaining the performance you get from having an on-prem data center and the security that comes with that. And the edge, really, when we talk about the law of the land, is really considering those things. So whether or not these are, healthcare data that needs to be handled very securely, perhaps captured at the edge, processed at the edge, but anonymized in some way, or it could be, as I say, it could be financial data or government data that needs to be kept in a secure location and processed even at a zip code or postcode level.
I love these three things kind of merged together, because to me we call them laws, but really they're, what's the right word? They're not even impediments. They're just the operating environment that you're in. I mean,
Yeah,
right?
like
You can't get away from it.
Guiding principles of how to think about what do we mean when we talk about edge, right? From a first principles perspective, why are we doing this? What are the driving factors? And as I say, I think these three laws, they're not really laws, but they do tend to guide your thinking when considering the why and the how and the what of edge computing.
So if we tie those now to what we call data characteristics, right? We've got data has characteristics in this environment that has these three laws. And what we talked a lot about this. A lot of people, when they think about data characteristics, the common things come up: data size, how frequent am I generating data, where is the data located, where it's being generated. And then you get into types of data. Is it like video data? Is it audio? Is it text? Is it, encrypted? All those sorts of things. And you have the privacy access. But the one thing I want us to delve into even more, and we've been hinting on it, is data spoilage. This was a new one for me. You guys introduced this concept to me, that data spoils over time, like the rotten bananas in my kitchen, right? You buy them green, no one wants to eat them, and then later on they're brown and no one wants to eat them again. There's that sweet spot, right, where you can actually do something with those bananas.
Yeah, no, totally. I think a lot about the perishable spoilage of data, and I think it's, you can, again, there's a number of ways to think about it. There's one of the use cases, or it's not even a hypothetical use case, but certainly a use case I think of. One of my years ago, I used to work in the broadcast and TV and media industry. Not on the producing, but on the the architecture and the business development kind of thing as a vendor, and we did a lot of targeted advertising. So, and I remember the shift between just carte blanche, blanket advertising where everyone gets the same ad, to that once the connectivity was introduced and you could start to understand a little bit more about who was viewing, you could actually put the viewer or the user into categories of advertising. So campaigns. So you'd have various campaigns that would have a profile, and you would, you'd match them up. And when the ads came on, you'd be able to target them with a specific advert, right? And when I think about that in the context of, data, I think there's a lot of parallels to it. So imagine maybe you've got your phone on you, it's connected, you've subscribed to an app that basically gives you offers around, wherever you are in the world. Now, say it's based in a city, and you're walking along the street, and the app, you've subscribed to it, so it's not imposing on your in your time and anything. You want it to notify you of stuff, right? So say you're walking down the street, and there's a lot of things fighting for your attention of what happens, and there's a retail store just ahead of you that has a number of offers on. They would really like you to walk into the store. When is the best time to ping me on the app, notify me on the app of when I should pop in the shop? Is it when I'm when I'm walking there, when I'm right outside, or when I'm already down the street thinking about what's on, right? Obviously, it's about as I'm approaching the store. You can get away with doing it if I'm stood outside, but in an ideal world, you want to be, letting me know that, hey, we notice you're about, 50 yards away from our shop. We've got a great offer. If you come in today, we'll sweeten it even further, or something like that. But if you try to use that data, oh yeah, this guy was walking past my shop the other day. It's like, who cares? And I think that is the epitome of the perishable data. It's like, yeah, did you know Alan was walking past, whatever shop the other day? And they're like, well, that's great and all. Maybe we'll get him next time. But by then, the shopping experience, that opportunity to bring me into the store has gone, right? I mean, lots of people probably would answer that question with the old automotive use cases, about breaking deadlock between in potential collision environments, and of course those are super high risk. And I think that's another part of edge computing, that the building of applications around real-time data, that there's the fun stuff like I just talked about, like, a shopping experience, the ability to do advertising, which is really important in a retail environment, but it's not life critical, right? It's not like
it's not critical infrastructure, right?
Yeah, but the same rules apply, even though there's a potential for accident avoidance. Like if you're in the Air Force, the Royal Air Force, you would have you have two different types of air traffic control, don't you? You have you have air traffic control, which is just dealing with people flying around in a non-combat environment. And then you have fighter control, which is dealing with, like, we really need to be keeping track of everything that's going on right now. And we need to be able to, and whilst the pilots are going to make their own decisions in a deadlock situation, we need to be able to answer it and react and provide them definitive life-saving, information from data in real time. Yeah. And it's like, so you got those two ends of the spectrum. You got the fun and you got the extreme like that.
Well, also what's interesting, let's go to the fighter control, for example.
Yeah.
I need that real-time information, but I also need to do, I hate to use the word post-mortem, but after the fact, I want to then go and say, what could we have done better? That goes into that training, right? Whether I'm training an AI model or I'm training people, there's still some additional value that comes out of data, which is wonderful. Unlike bananas, right? Once they're spoiled, the only thing I can really do is banana nut bread, right? Or banana bread. And that's all I get out of it, right?
Right.
So there's still, even though there's data spoilage, there's still some intrinsic value out of data, even as it spoils.
Yeah, I'm laughing because we're a big fan in this family of banana bread. It's like
there you go.
We let our bananas spoil because we know we're getting banana bread.
Because you're getting banana bread. That's awesome. All right, so we've talked about we talked about all these characteristics. We've talked about the operating environment, the laws. Mm-hmm. Let's talk briefly about the architectures that help us take advantage of the environment that we're in. Because
Mm,
I can't just say one architecture is going to solve all my problems. We already know that.
mm.
But there are some distinct architectural approaches to solving these problems that we're talking about, especially with edge computing and data, um, uh, with all these different characteristics.
Yeah, yeah, totally. And I think that this is, this is what I've seen over the years of working in the edge space. And I think it does relate to obviously the laws as well. It would have to, wouldn't it? But you can put compute pretty much anywhere you want, and within reason. And and if you are part of the value may be derived from unique points of presence itself, that you can take advantage of. Otherwise, it's multi, what you call it, neutral hosting, right? So anyone can put some hardware in there, and that's a great model. The next step up, so you're talking about infrastructure as a service at this point, and that gets you so far. But at some point, you're going to want to build an application to run on that compute. And if you're just running it in a single location, then maybe the proximity and the location is sufficient for you to be able to almost, if I can use the term, lift and shift from wherever it is to that edge. But as soon as you want to get what I said earlier about the that consistency of experience, whether it's a human or a device or whatever, on a distributed stage, right, and a distributed system, that becomes more challenging. And it's not so easy just to pick off the shelf a few components and just say that's my tech stack and it's going to work globally, because this is complicated stuff to build a distributed system. It's like, how do you handle the consistency and reconciliation of data in a distributed system whilst letting you put APIs on it? How do you deal with data at rest and data in flight? We're talking about real-time data here, right? So there's predominantly, you can be amiss at thinking that we're just focusing on data that's being generated in the moment. But to your point a few moments ago, the banana bread, right? Part of say you're doing an ETL process, part of that process could be complex joins and data enrichment as you're processing, extracting, transforming, and lifting the data, right? So you need to you start to get into this very complex environment where you realize that your application needs almost a smorgasbord of technologies to actually realize the kind of things you want to do. And all of a sudden you're getting a lot of complexity. And I guess, as Chaitan always says, computer science is always about, abstracting complexity, right? And that's what we've done. We're a very opinionated platform. And I say opinionated because we know through our experience the kind of technologies that you need to have pre-integrated and customized to be able to build these kind of high performance real-time applications that can take advantage of data that has been collected and is available for historical, but then also allow you to combine it with real-time data to provide real-time actionable insights on a global scale. And I think that's, to your question, that is the real challenge of edge computing. It's like, how do I go from a desire for a performance improvement for my application, whether or not it's a law of physics, whether it's an economic, or whether it's a law of the land, to then actually taking into account, how does this work on global scale? Okay. And that's the real challenge of the edge.
And yeah, and I love that approach, because that also says, because I'm taking into consideration the three laws, it says that I'm not necessarily processing all the data on the edge. I'm processing it in the ecosystem, which gives me flexibility, right? And I need that flexibility because, as we mentioned, sometimes I need that real-time insight, and sometimes I need the data to spoil to produce great banana bread.
Yes,
right?
exactly.
Where I'm combining stuff from other things, and it takes more time. So I can't just say, no, everything's out on the edge or everything's centralized. It's got to be I have to be able to support multiple modes. And that's
Yeah.
what I really love about your guys' approach to this.
Yeah, I mean, this is the thing. I mean, data. Sorry, I was going to say something else, but the distributed systems are not just. It would be wrong to assume that a distributed system simply means, I'm replicating the exact same part of my application across every point of presence that I have available to me. Back when I was at university, I on my placement year, I used to work with transputers, if you remember those, Darren. And we'd have one transputer that did one thing. I don't remember the model numbers; it's too long ago. But we had one transputer that was good at one thing, and another transputer that was good at another thing. And the trick there was to do parallel processing, written in Occam across these transputers, and use them for the for the appropriate value that they bring, right? And you can draw a parallel, no pun intended, back to distributed systems in cloud computing, right? So you've got the edge that's perfect for doing real-time fast data processing to generate insights and all kinds of other cool things at the edge. And then you can use a more centralized approach for like your machine learning. So you have that idea of a reinforcement learning is a great example. So federated or distributed reinforcement learning, where you are running your inference at the edge, but your model training and update is handled centrally, and then you're doing an update of the edge inferences dynamically. So you're combining the best of both historical data and real-time data, and not only that, the insights, right? So you it's not just, yes, I've got my real-time data, my historical data, but you want to see what did you do with that data, those insights, and then how do you feed all that back and then retrain and improve the model itself. So you're talking about building distributed systems, not just moving stuff from central locations to the edge. You're talking about building high performance applications that use the capabilities that are in the industry today in the best possible way for your application.
So this is great, Alan. I think we've kind of shown everyone, hey, this is the problem space that we're in. You guys have, I think, a unique and fascinating architectural approach to this by handling all the complexity that's in a global data mesh, handling function as a service on top of that, and the data governance part of that. We should spend a whole nother podcast just going more in depth into your guys' architecture. But we don't have time today because we're already out of time, which really kind of stinks.
You could read the white paper. That's probably,
read the white paper.
That's a good primer, and we can always redirect people to the website, and they can read more about it there. So, and we got lots of
in fact, check out our website. You can find on embracingdigital.org. You can find a link to the white paper. Check out MacroMeta. .io or .com?
It's macrometa.com. Yeah.
.com. All right. Yeah. Macrometa.com. And I'm sure you guys have a link up there to this wonderful white paper that Alan and I wrote. So Alan, it's been a pleasure having you on the show today.
Yeah, thank you very much. My pleasure as well. Thank you.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.